Okay, so I got a student request to do 4 more practice problem 7.2, which I have pulled up here, and I am going to pull my marker out and start it. Okay, so let's see, what color am I? Red. It says red right here. Okay. So 4 more practice. The energy required to dislodge electrons from sodium metal. All right, I'm going to first of all make a note here. To dislodge electrons, I don't think I need that to be written as the work function or the binding energy, but I'm going to write it. Okay, that's the energy required from sodium metal via the photoelectric effect is 275 kilojoules per mole. Okay, mole of what? Mole of photons, or mole of electrons, right? Because it's 1 photon per electron. Okay, what wavelength in nanometers of light is sufficient energy per photon to dislodge an electron from the surface of sodium? So it's asking what wavelength, okay, and it's going to be in nanometers, right? So I'm going to come here, and I'm going to say nanometers to meters, okay? Then I'm going to come up here and make some notes. E is equal to hc over lambda, and this is the energy per photon, okay? This is going to be in joules per photon. All right? So now I'm just going to come through. You know what? I don't have a whole lot of insight right now, so I'm going to go here and say, I'm going to come, my C is equal to meters per second. H is equal to joules seconds, right? So it looks like I'm going to need C here for this because I need meters, right? See it right here? Meters per second. So those will cross off. You see that? Those will cross off. Then I'm going to need to cross off joule seconds. So this is joules seconds. You see that? Okay, those will cross off. Okay, and this is not a ratio. This is just a constant. All right. Now this is joules per photon, right? So I'm going to have to go with joules. That's for 1 photon, right? Now I got to start over again.
Sorry.
Nah, it's okay.
What did you do?
I got lost. And it's not gonna. It's gonna be hard for the students if I get lost. Okay, so a student asked for a question from 4 more practice 7.2. So let's look at this. We're not doing this one up here. Okay. The energy required to dislodge electrons. Okay, I see dislodge electrons via the photoelectric effect, and I think binding energy. Remember that? Okay. Now we're not going to put it into a formula, I don't think, but I just want to make notes, right? Keep everything categorized. Via the photoelectric effect is 275 kilojoules per mole. 275 kilojoules per mole. Per mole? Per mole of what? Per mole of photons. Per mole of electrons, right? Because it's 1 photon per electron that gets knocked off. Okay? So that's that right there. What wavelength in light has sufficient energy per photon to dislodge an electron from the surface. All right, so we want the energy of one photon. This is for a mole of photons, right? Can you see that? What wavelength has a sufficient energy of light per photon? I'm sorry, I said that wrong, but sufficient energy per photon. And remember that E is equal to h nu, which is equal to hc over lambda, which is the energy per photon, or energy of a photon. Remember that? Okay. So first of all, let's convert the energy of a mole of photons to the energy per photon. Okay? So the energy per photon is going to be joules, kilojoules, right? Because I was given kilojoules up here. And I'll have kilojoules per mole of photons, right? I'm going to have mole of photons and photons. Now this stuff will all cross off, right? Let's kilojoules cross off, joules I have, photons I have, and these guys cross off, right? So let's put the numbers in. There's 6.022 times 10 to the 23rd photons per mole of photon, right? And there's 275 kilojoules per mole of photons, right? And there's 1,000 joules per kilojoule. Agreed? Okay, so I'm going to get rid of that 1,000 and make that a 20, right? And I'm going to go ahead and calculate 275 divided by, when I do that, it gives me less things to calculate, right? So it's 275 divided by 6.022 times 10 to the 20 equals 4.567 times 10 to the minus 19. 4.567 times 10 to the minus 19 joules per photon, which is also equal to, watch this now, hc over lambda, which is, I'm looking for lambda, right? It's asking what's the wavelength. Okay, so I'm going to rearrange this equation here. And the student who asked me is pretty good with algebra. I'm just going to go ahead and do this now. This is going to equal lambda is equal to hc over E, where this is E. Right? That's the energy of a photon. Okay? So this then becomes 6.626 times 10 to the 23rd joule seconds times 3.00 times 10 to the 8th meters per second, right? Over 4.567 times 10 to the minus 19 joules, right? Now the joules are going to cross off, seconds are going to cross off, and I'm left with meters. You know what? Let's do the conversion of meters to nanometers real quickly here, can we? There's 1 billion nanometers in a meter, and so that's going to be our answer. Okay? Pause the video now and calculate it. Make sure you get the same answer I get. Pause it. Obey me. 6.626 times 10 to the 23rd times 3 times 10 to the 8th times 1 times 10 to the 9th divided by 4.567 times 10 to the minus 19 gives, oh, that can't be right. Something's wrong here. Oh, there's a mistake. So I got something times 10 to the 59. I can't believe I did that. Look at that. That's not right. It's minus 34. Look at that. Sorry. I'm going to do this again. if I'd have done my shortcut there, I would have seen that earlier. 6.626 times 10 to the minus 34 times 3 times 10 to the 8th times 1 times 10 to the 9th divided by 4.567 times 10 to the minus 19 gives 435. That makes sense. Right? That makes sense because it's light. It says wavelength of light, and that's definitely in the visible range. Right? Because it's 400 nanometers. Okay, so I believe that it makes sense. I'm not even going to calculate. Well, yeah, I'm going to calculate it one more time, just in case. 6.626. But this time, you know what I'm going to do? I'm going to go to another layer. No, I can't do that. I don't have room. I'll come over here. And I'm going to say 10 to the 23rd. I'm going to just do that. I'm just going to do the, I did it again. Minus 34. Plus 8, plus 9. And then plus 19 is on the bottom, right? So it's going to be 10. I can't do that in my head. 17 plus 19. What's 17 plus 19? 36? Yeah, this is going to be 10 to the 2. Okay? So this is going to be 6.626 times 3 times 1 divided by 4.567 times 100. Right? That's what that's going to be. Should get the same number here. If I don't, I'm going to calculate it again. 6.626 times 3. Whoops. 6.626 times 3 divided by 4.567 gives 4.35 times 100. Awesome. 435. So I checked that one, and it is correct. 435.